Right, guys, now I'm going to do task 27. This is the task that we have done today. Okay, question 1. Simplify the following expressions. Okay, let's start. Okay, so we said, guys, when we see these type of questions, addition and subtraction of rational expressions, just like the fractions, we're going to make the denominators equal, and then we continue with the question. Okay, if I look at here now, the first fraction here, guys, is 2 over x minus 2 over x plus 1. So the denominator for the first one is x, the second one is x plus 1. So I have to make them equal. Okay, so I'm going to say, write x plus 1 for this. And then I'm going to say x for this. All right. Then we said when we're using anything to make the denominators equal, we're going to multiply it with the denominator as well. All right, so if I do that, it's going to be the first one, 2 times x plus 1, 2 times x plus 1, right, over, right, x times x will be x squared, and x times 1 will be x, so it's going to be x squared plus x, right, minus x times 2x is going to be 2x over x squared plus x. Okay, so now I can work with this here in the top part, 2 times x, so that this will be equals to, right, so I'm going to say this equals to 2 times x. I'm just going to do this. Right, it's going to be 2x plus, right, 2. 2 times x, 2x, 2 times 2 is 2 over x squared plus x, right, minus 2x over x squared plus x. Right, then this equals to, okay, 2x minus 2x is going to be 0, right? What do I have? Yeah, okay, let's do it. So 2x plus 2, right, minus 2x. Because now my denominator is the same, so I can just simply subtract the numerators. Okay, x squared plus x. Right, so this equals to 2x minus x, guys. As you can see, 2x minus x. So this will be 0. On the top, what do I have left there? 2. Right, and then at the bottom, what do I have? X squared plus x. So this is going to be my answer. All right, so we make the denominators equal, and then whatever we're using to make the denominators equal, at the same time we multiply with the numerator as well, and then we just simply follow the rules of the addition and subtraction with the fractions, same rules. Okay, okay, let me continue with question 2. All right, question 2, I have x plus 1, you have x minus 1, guys. Before I start with this, we just need to remember that x plus 1 times x minus 1 isn't this, guys, difference of two squares? So it's x squared minus 1 squared, right? X plus 1 times x minus 1, difference of two squares, we take one positive, one negative. So, but this also equals to, right, let's continue, this equals to, if I say this equals to x squared square minus 1, right? Because I write it in this form to see that it's difference of two squares, right? because 1 to the power of 2 is 1 again. So this is basically this. Right, by knowing that, right, let's do it. We're going to make the denominators equal. So I'm going to say x minus 1 times that. I come here, x plus 1. Okay, so that equals to, okay, let's continue with that. We're going to time this with the numerator. X times x will be x squared minus x times 1 will be x over, right, I'm going to write this, x squared minus 1 plus, come here, x times x, because we need to time this with that also, as we did here, right, x times x will be x squared, right, then x times 1 will be plus x over x squared minus 1. Then I'm going to say this equals to, right, this equals to what? I'm going to add them together. I'm going to say, can you see here, because I have the same denominators now, I'm just simply going to add the numerators. Minus x plus x squared, right, plus x over x squared minus 1, because I have the same denominators, guys. That's why I'm adding the numerators together. So x squared minus x plus x squared plus x. So something will be cancelled here. X, negative x plus x, guys. This will cancel each other because negative x plus x, that will be 0. Right? So x squared plus x squared. Then I'm going to have 2x squared. Because 1x squared plus 1x squared is 2x squared over x squared minus 1. And this is going to be my answer. Okay, so let's continue with the next question. Okay, next question, what it says. Okay, let's see. Okay. 1 over x plus 2 over x minus 1. So it's the same thing. I'm going to say this times x minus 1. And this times x. Right? Then it equals to what? Again, this will be multiplied with this as well. Just going to show that. So 1 times x minus 1 will be x minus 1 over x times x minus 1 will be x squared minus x. Right? Then plus x times 2 will be 2x over, again, x squared minus 1. Squared minus 1. So my denominators are equal, so I'm just going to add the numerators together now. Okay, then it is going to be, just going to write it here, x minus 1 plus 2x. Right, so isn't that going to be, right, that x plus will be 3x, oops, 3x minus 1 over x squared minus x. Okay, so this is going to be my answer. All right. Okay, now, all right, we're done with this one too. Let's continue with next question. Let's see. All right, this question, Okay, so it's 3 over x minus 5. Guys, we did say that all the whole numbers can be written as fractions if we add 1 to their denominator. Let's add 1. Okay, so now it's going to be 3 over x minus 5 over 1. So then this is going to be 1, right? This is going to be x, right? Then it equals to, all right, 1 times 3 is going to be 3 over x minus x times 5 will be 5x. Okay, 5x over x times 1 will be x. Right, then this is going to be 3 minus 5x over x. So this is going to be right, the answer. Okay, so now let's continue with next question. Okay, let's see what we have next. Question 4. Now we have a question 5. Okay. Right, question 5 says 1 over x minus 2 plus 3 over 1. Then I'm going to say, okay, this is going to be times 1, this is going to be times x minus 2. That equals to this. Okay, right, so 1 times 1 is going to be 1 over x minus 2 plus, right, 3 times x is going to be 3x minus 6 over x minus 2. Right, that equals to 1, okay, plus, okay, I'm gonna write it here now. Since I have the same denominators, I'm going to add the numerators. 1 plus 3x minus 6. So it's gonna be 1 plus 3x minus 6 over x minus 2. Right, then I'm gonna see that equals to, I'm gonna continue from here, equals to 1 plus 3x minus 6, that is going to be, right, 3x minus 5 over x minus 2. All right, so that is going to be my answer, 3x minus 5 over x minus 2. Right, let's continue with the next question, see what we have next. Okay. Oops. Okay, let me just, okay, move on to the next one. So, question 6 says 5x over x minus 3 minus 15 over x minus 3. Guys, as you can see, x minus 3, x minus 3, I have the same denominator. So what I'm going to do is this. I'm going to say 5x minus 15 over x minus 3, because I don't need to do anything here. I already have the same denominators. Right, but when I continue with this, guys, just remember this, 5x minus 15. Right, what is common here? 5 and 15. What is common? Obviously, it's 5. So if I take 5 out, the common factor out, what will be left here? X minus 3, right? Because if we do an inverse operation here, 5 times x will be 5x, 5 times negative 3 will be negative 15, right? So over x minus 3. Right, so as you can see, guys, right, x minus 3 and x minus 3. So this will cancel each other. So I'm going to have 5. So only 5 is left. So this is going to be my answer. Okay, let's continue with next question. What question is it? Question 7. All right, question 7, guys. A minus 5 and then 5 minus a. I think I explained this in class, guys. We do get confused with this. You see now, a minus 5 and 5 minus a are two different things, but we can get them the same. So I did say that in class. If it was 5 minus a, right, say, divided by 5 minus a, guys, this equals to 1 because it's the same thing. It's like 2 divided by 2 or 5 divided by 5. 5 minus a is a term and 5 minus a is a term. So that divided by that is going to be 1. But if it is like this, right, then 5 minus a divided by a minus 5. Okay, this is different than that. Okay. So then, because this and this are the same, guys, and this are different. But if I multiply any of this with a negative 1, it's going to be same as the other one. Say if I multiply this negative times, right, 5 minus a. What's going to happen here? This is going to be same as this one. Negative time will be negative 5. Negative time negative a will be positive a. So it's going to be same as this. That means, guys, I can get them the same if I multiply one of this by negative sign, right? So if I do that, then it's going to be, see here, a negative 5a, right? Then negative time negative, guys, which is going to be positive. That's why I'm going to say that this is 5 minus a, so I multiply with negative sign, and that negative sign, I'm going to multiply with this as well, because you see here, guys, it's a negative sign. Negative time negative is going to be positive. Then if it happens, right, that's positive, then what's going to happen? A minus 3 in this case, yeah. But if this sign becomes positive, it's going to be what? It's going to be a plus 3 over, right? So we're going to say this is going to be 5 minus. Okay, so it's going to be, right, over, it's going to be a, so let's say if I multiply that, it's going to be a plus 3, because I multiply this one, it's going to be a minus 5. Okay, this doesn't look like 5. 3, right, 8. Okay. Again, guys, you see here, this is a minus 5. This is 5 minus a. To get this 5 minus a, I'm going to write it here. To get this 5 minus a, right? This 5 minus a, guys, the same as this one. I need to either multiply it 5 minus a with negative sign or a minus 5 with negative sign, right? To get them the same. In both cases, it will change this negative sign here, so it's going to be positive. So it's a minus 3 will be a positive 3, right, over a minus 5, because now we got them the same. We have to make them the same. Okay, so, and then we, okay, this one is 5 minus a and 5 minus a, that I was speaking about that rule. okay, before I forget it, is 1. So 5 minus a divided by a minus 5, that this is basically negative 1, right? So this is negative 1, then negative times this negative will be positive, so a plus 3 over a minus 5. All right, next question. Okay, question 8. Right, let's see what is happening here. Okay, I have 3x to the power of 2 here in the denominator, and here I have 12x. And then in the numerator part I have 2 and 15. So when I look at this, guys, I need to figure out now what is the common factor here. Okay, so I'm not gonna try to keep it long, guys. It's basically 4, right? Both sides I need to multiply by 4, guys. Sorry. Okay. This is right 4, and this is going to be x. We'll tell you why now. Right, 4 times 3x squared. I'm just gonna write that here. Y is 4. Okay, times 3x squared, guys, equals to 12x squared. Right, and then 12x times x, 12x times x equals to, guys, 12x squared. Right, that's why I use x for this, right? 12x, because x times 12 equals 12x will be 12x squared. 4 times 3x squared will be 12x squared. So now my denominators will be equal. Then we said we're going to multiply this with the numerator as well. So let's do that. Right, so once we do that, then it's going to be like this. I'm going to rewrite it here. 4 times, what is in the numerator part? 2. 4 times 2 is going to be 8, right, over 12x squared, right, minus x times 15 will be 15x over 12x squared. Right, my denominators are the same, so I'm going to do this 8 minus 15x. I can't do anything to that, so it will just stay like that. Right, that equals to 8 minus 15x over 12x squared. And okay, then it's going to stay just like this. So this is going to be my answer. Again, guys, I use 4 for 3x squared, and then I use x for 12x, because 4 times 3x squared will be 12x squared, x times 12x will be 12x squared. So this is how I can get my denominators the same. Then we do know that whatever I used to make the denominators equal, at the same time we'll multiply that with the numerator as well. So 4 times 2 became 8 over 12x squared. X times 15 will be 15x. X times 12x squared will be 12x squared. So once my denominators are equal, I can work with the numerator. So 8 minus 15x will be 8 minus 15x, right, over 12x squared. And this is going to be my final answer.